In Part 8 of Lecture 2, we will discuss fault tolerance. Fault tolerance refers to the ability of a system or component to continue normal operation despite the presence of hardware or software faults. This typically involves some degree of redundancy. Fault tolerance is intended to increase the reliability of a system. Typically, increased fault tolerance, and therefore increased reliability, comes with a cost, either in financial terms or performance or both. Thus, the extent adoption of fault tolerance measures must be determined by how critical the resource is. The basic measures of the quality of the operation of a system that relate to fault tolerance are reliability, mean time to failure, and availability. These concepts were developed with reference to hardware faults, but apply more generally to hardware or software faults. The reliability, R of T, of a system is defined as the probability of its correct operation up to time t, given that the system was operating correctly at time t equals 0. For computer systems and operating systems, the term correct operation means the correct execution of a set of programs and the protection of data from unintended modification. The mean time to failure is the mean time between failures during the useful lifetime of repairable or redundant systems. The mean time to repair is the average time that it will take to repair or replace a faulty element. The availability of a system or service is defined as the fraction of time the system is available to service users' requests. Equivalently, availability is the probability that an entity is operating correctly under given conditions at a given instance of time. The time during which the system is not available is called downtime. The time during which the system is available is called uptime. This figure illustrates the relationship among the parameters. The time periods A1, A2, and A3 indicate the time periods when the system is down or unavailable due to a fault. The time periods B1, B2, and B3 indicate the time periods where the system has or can have normal operations taking place. If we add the time periods A1, A2, and A3 and divide by 3, we will find the mean time to repair. If we add the time periods B1, B2, and B3, we will find the mean lifetime between failures. Availability is the mean lifetime between failures divided by the sum of mean lifetime between failures and the mean time to repair. The table in the slide shows commonly identified availability levels and corresponding annual downtime. In the case of continuous service, the system is always available and therefore availability is 1, with annual downtime of 0. Fault tolerant, you'll notice that we have here that the availability is 0.99999 for an annual downtime of 5 minutes. And from here you can see levels that go down overall. Normal availability would account for an availability of 0.99 to 0.995, with annual downtime between 44 and 87 hours. The IEEE Standards Dictionary defines a fault as an erroneous hardware or software state resulting from failure component, operator error, physical interference from the environment, design error, program error, or data structure error. The standard also states that a fault manifests itself as a defect in a hardware device or component, for example, a short circuit or broken wire. Or 2, an incorrect step, process, or data definition in a computer program. We can group faults into the following categories. Permanent, a fault that, after it occurs, is always present. The fault persists until the faulty component is replaced or repaired. Examples include disk head crashes, software bugs, and a burnt-out communications component. Temporary, a fault that is not present all the time for all operating conditions. Temporary faults can be further classified as follows. Transient, a fault that occurs only once. Examples include bit transmission errors due to an impulse noise, power supply disturbances, and radiation that alters a memory bit. Intermittent, a fault that occurs at multiple unpredictable times. An example of an intermittent fault is one caused by a loose connection. In general, fault tolerance is built into a system by adding redundancy. Methods of redundancy include the following. Spatial or physical redundancy. Physical redundancy involves the use of multiple components that either perform the same function simultaneously or are configured so that one component is available as a backup in case of the failure of another component. An example of the former is the use of multiple parallel circuitry with the majority result produced as output. An example of the latter is a backup name server on the internet. Temporal redundancy. Temporal redundancy involves repeating a function or operation when an error is detected. This approach is effective with temporary faults, but not useful for permanent faults. An example is the retransmission of a block of data when an error is detected, such as is done with data link control protocols. Information redundancy. Information redundancy provide fault tolerance by replicating or coding data in such a way that bit errors can be both detected and corrected. An example is the error control coding circuitry used with memory systems, and error correction techniques used in RAID disks, discussed in later lectures.